All right, here we are. This is Mr. Matroni, and this is Scientist Joe. You ready to do another experiment?
Yeah.
Okay. So did the other experiment go well?
Yeah.
Okay. You seem very talkative today.
Yes.
Good. Okay, so what we have is we are going to have, these are agar cubes. Now, agar is actually made from seaweed.
What?
Okay? Yeah, seaweed. So it makes it nice and solid. It's like Jell-O. It's like gelatin.
Yeah,
and so we
that's
have
what
a,
I'm saying.
yeah, so we have 1 centimeter on a side, 2 centimeters on a side, and 3 centimeters on the side. Now, as you get bigger, what do you think happens to the amount of gelatin you got? Does it go up by a little bit or a lot?
A lot.
A lot, yeah, because you have all 6 sides, which are now getting bigger. And so you get this big, what's called a volume. All right, notice, is there anything interesting about their color?
They're purple.
They are purple. They have a material in it called phenolphthalein. And phenolphthalein, what it does is that it will turn colors if it's in an acid. So I have acid here. This is hydrochloric acid. And it's 0.75 molar. So it's pretty concentrated stuff. So we want to be real careful with it. So we're not going to drink it.
I would never drink something like that.
You're not going to give it to your sister.
I would never. She would break the bottle.
She would break the bottle. That's true.
She's a monster.
She is a monster. Okay, so this is the sheet that it's going to go with, which is called diffusion with agar blocks. Okay, so diffusion within agar blocks. Now, here we go. What we're going to do in just a minute is you're going to take the different agar blocks and we're going to put them in the acid. Now, the way to put them in the acid is you don't just drop it. You ease them in, okay? And
Like
I'm going to
a ramp, like sliding them in with a ramp?
Exactly. And we're going to get a timer on here. So we're going to do the stopwatch. We're going to see how long it takes. So, first things first. Why don't we start with the biggest block, and then we're going to go to the big, middle, small. So there you go. And once again, you're just going to let them slide in. Just slide in. Ooh, there goes the first one. Okay, so here. Take the second one and put it in.
On the side it looks extra big, but on the top it looks smaller.
Yeah, try putting that guy in. Ah, here we go. Help you out there. Boom, there you go. Okay, put it in. There you go, perfect. And then we have this last one. Here you go, and put it in. And I'm gonna start the timer. All right. So, immediately, do you see what's starting to happen?
Starting to turn the water purple.
Look at the sides of the cubes. Are they staying purple or are they becoming clear?
Becoming clear, that's cool.
Yeah. So if you take a look, you'll notice that they start becoming more and more clear.
Don't burn the iPad.
We're going to notice that. I'm not going to burn the iPad. So we're going to notice. Okay. So we're going to let this stay this way. And we're going to, every now and again, give it a little bit of a stir to allow it to go and to get all the way through. You don't want it just sitting on the bottom. We want it inside the solution because you want to give it access to all parts of it. Okay, so we're going to pause it now and then like a cooking show come back. Okay, Scientist Joe, let's take a look. It's been a couple minutes now. What are you noticing is happening to these cubes?
It's turning clear, so the outside outline is white, but the inside is purple. Here, let me take out the spoon so you can see it a bit.
Thank you. Yeah, and you notice the cube inside there. Oh my gosh. So the acid is going in, and as the acid goes in, it turns the phenolphthalein from pink to what color?
Clear, but is there an outside layer of something that protects it from turning that color?
That's a great question. No, the acid is going through, it's called diffusing. It's diffusing inside of these particular cubes. Now question, which one do you think is probably going in faster? The big cube, the middle cube, the small cube, or do you think they're all going in at the same rate?
I think the bigger cube.
Think maybe the bigger cube? Well, that's something to keep in mind, and we're going to actually figure it out.
Ooh, fancy.
Okay. As we can see, the cubes are getting more and more white inside as the acid goes in. And so the cube's becoming smaller, smaller, smaller of pink. Now, what you folks are going to do is, on this sheet, you're going to notice that it talks about the sketch of the cube, total surface area, volume, and surface area to volume ratio. So you're going to calculate all those out. Remember, they're cubes, so it should be pretty easy to do an area and to do a volume. Then what we're going to do is we're going to take a look. We're going to try to figure out the rate of diffusion, how quickly it goes in. So, Joe, as we take a look, we don't have that too much more to go, but when we get there, we'll be right back and we're going to slice them in half.
Yes, I love slicing.
Okay. All righty. So now we're taking a look at this, and it looks like the little cube has finally become completely has turned white. Oh, actually, there's just a little bit in the center, tiny amount. And that's okay, because that'll keep diffusing. All right, so I'm going to take this guy out now, if you want to back up a little bit. And what you're going to do, Joe, is take this guy and cut straight through the middle. So take the knife, cut straight through the middle. Okay?
So like that?
Yeah, go straight through the middle. Excellent. And look at that.
That is cool.
And now go to that one. Yeah. Okay, and cut through that guy. Straight down the middle. Good job. Boop. And then that last one, the little one. Straight down the middle. Excellent job, bud. All righty.
Wow.
So, boop.
Oh,
So, if you could come down and being able to take a really good look, maybe come over the top. So what we're going to do is we are now going to measure how far it went. And we'll notice, boom, 1/2 centimeter. And this one, 1/2 centimeter in. And this next size one, we'll take a look and we'll go, oh my gosh, it's 1/2 centimeter. And that one's 1/2 centimeter. Huh. Hey, Joe, this one went completely through. It was 1 centimeter. So how much do you think it went in on each side? A lot. So it went, if I have 1 was the whole thing, then it's halfway in from one side, halfway in from the other side. And just so we know, the timing was 9 minutes and 35 seconds. It'd be 9 minutes and 35 seconds. And then we have these guys going in 1/2 centimeter. So on this, rate of diffusion is going to be in centimeters per minute. And so you're going to go and calculate how far it actually went in. And then we're going to go and figure out these different things. Take a look at the volume, which is still pink. And think about it, if it came in 1/2 centimeter this way and 1/2 centimeter that way, what is the actual size of the cube, which is there?
There's no
and what's the size of the
volume
cube?
on it.
Well, there is a volume because it has length, height, and width.
But volume sound. And it doesn't make any sound.
You know what? That means that there's different definitions for volume. That's a great thing. That's very cool. So this is what we've got and we're working with. So the whole goal of this is to figure out which one diffused the fastest. The smallest one, the medium one, or the biggest one.
Smallest.
You think it's the smallest?
Smallest.
We're certainly going to find out. Okay, now we're going to do our calculations. Hey, Scientist Joe, thanks again for your help. Science rules. So Joe, what are you doing?
Chopping them up into smaller pieces.
So you know what we saw was when they were really big cubes, they didn't get all clear, right? There was still parts that were pink, right?
Yeah.
Okay, let's do this. What happens if we took all these little bits and put them in? What do you think would happen?
It would disintegrate faster because there's less to disintegrate.
So they go clear because there's less area for them to go in, right? So let's do it. Here.
Wait, I need to chop one more thing.
Okay, good. Now, I'm going to take these and let's put them inside here. Boop. So I'm going to put them in. And how quickly do you think they're going to all go clear? Quick. Because what happened to the size of the pieces of agar that are in here?
Wait, what's agar?
That's this stuff. Is it a goggles on?
Oh.
Are these pieces of agar bigger or smaller?
Is agar the clear part?
Well, just these little pieces of stuff. Are they bigger or smaller than before?
Smaller.
So what do you think's going to happen?
It's gonna disintegrate faster.
Well, it's gonna diffuse. Now, you know what? It's not going to diffuse any faster. It's just that there's less area and less volume for it to go into. So would I want to be made out of one really big cell or a bunch of little cells?
A bunch of little cells.
Because then I can get food to them and waste out and I can survive.
Like donuts.
But
and cake and cookies and brownies. Mmm.
I don't know what she's talking about.